Oh, okay. So, hi everyone. So for the introduction, we'll have our fellow grad, Karthik, to start us off.
So
Yeah,
can
he's
all of
virtual, by the way. Yeah.
yes, I was supposed to say that. Sorry, I was supposed to be there in person, but yeah, attending online. So can you all hear me fine, or is there any audio issue? All good?
Yep.
Okay, excellent. So hello everyone. So we are Team Housing and AI. Let me first introduce my team here. So my name is Karthik Hanumantaya. I'm a graduate student in Department of Computer Science, and I'll also introduce three serious faces that are standing there. So first one is Alistair. So Alistair is a sophomore in majoring in data science, and we have Neha there. She's a junior in Department of Computer Science again, and minoring in data science. And we have Kale over there. He's a senior. He's majoring in data science, and if I'm not wrong, Kale minoring in economics. Yeah. So we also have Lisa here. Lisa, she's a client for our project. She helped us guide the project from the goal point, and we also have Liesel here who helped us every day, in getting the project done, right? Let me then move to the project, what we are really trying to do. So this is the second year that we are trying to, we also had the project for in the last year, trying to make use of AI in the housing sector, more specifically in the inspection, housing and inspection. So this year we took a more broader question of how we can help the housing community in terms of information access. So that was our research question. We started with how we can help housing and community people to get the information more accessible. The image block image that you see there in the goal section, we that's where we started. How the research question was how we can make that housing information that is easily accessible, and then get them most up-to-date information in terms of analytics, in terms of visualization. How can we do that? So that was the research question that we started with. In order to validate this idea of this specific information the community is looking for, we sent out a survey for the people to answer what information are you people lacking to get your job done more effectively. We received good amount of response from different roles, different roles from local officials, community planners, and then the people who are working in the extension, the research people who are working in the housing and community sector, and also the homeowners, right? Homeowners and others who are looking for public housing or affordable housing. And the next image, Alistair, if you move. So most of the information that people were looking are around affordable housing, and then neighborhood amenity access, and then things around financial support from federal or state around housing, and much more information. It's not that none of this information are available uh, in any of the government websites or the documents that are provided by released by the agencies. It's just that it is available in bulk at different places. Accessing or getting hold of that right information that they are looking for was a particularly difficult problem for all of these roles that are working around housing and community development. So that's where we started looking at what are the technologies that we can use to help these people to get the right access in a most easy and convenient way. So, and is also the reason why we took machine learning approach here. There are two main problems that we are trying to address in terms of information access. One is, if you want to give them right information, you first need to understand what exactly the user is asking for, right? So that would be the first core component that we need to understand. And the second component is we also need to understand what information that are already available, right? It's not just a simple keyword search, but it is more than understanding the content that are already available and trying to, based on the context that user is providing, trying to answer most relevant answer. So that's where we started thinking in terms of, because machine learning is good at doing this job, let's try to use machine learning to address some of these issues. And another thing that from our last year of housing project, that what we learned was we don't have rich access to the data sets, right? So that was one of the learning from our last year housing project. So what we did this year is we wanted to use machine learning, but we also wanted to look at some of the ways that even with the limited set of data access that we have, that we can build a good uh, application or tool here to help all these different roles. So so my team will more talk about all these different technologies, and we have a bunch of scenarios or demos that we have planned here. Each of them, believe me, is more exciting than the other. So what I request you is, these scenarios are tailored in such a way that it gives you an idea of what these models are capable of doing. And I'm sure that the people who are working in field would have more idea of how we can rightly use this technology. So by the end, we would really like to hear your feedback or the ideas that you have on how we can make use of these technologies. So I'll hand over to Alistair now, so he'll talk more about it. Thank you.
Okay, thank you, Katrik, for that wonderful introduction. So before we dive right into the gist of the project, I would like to bring everyone's attention that we will be covering for today. So we will start us off by going through some of the technology overview, followed by data overview, and we have the whole overall project overview, some of the use cases of our AI chatbots, followed by a simple wrap up, and some of the future work and challenges that we might embark on in the future. And last but not least, we'll open up for a time for questions. So for the technology overview, so the primary foundation of our AI chatbots is machine learning. I know the word machine learning was being thrown around a few times just now. So what exactly is machine learning? So machine learning is a tool that enables the AI to learn to understand how humans can speak and learn to bridge and speak and learn to bridge the gap between AI and human communication. So large language model is a subtype of machine learning that we have been using for our AI chatbots. So it is being trained on the vast amount of text data to be able to understand the human language. This is very important for our project because by understanding the user's question, the AI chatbots is able to interpret and understand before sending a right response to the user. We'll follow through by going through some of the data resource that we have been going through throughout the whole project. So we'll start us off with the American Community Survey, or better known as the ACS. So for the ACS data, we are primarily looking at the ACS 5 years from the year 2017 to the year 2022. And we also have the data for decision makers. So it is a brief report that consists of different cities, counties, as well as the region's demographics, economics, social health, and most importantly, in our case, housing characteristics. We also have the Rural Housing Readiness Assessment, or better known as the RHRA. So it is actually a tool that helps us to understand what exactly a community's needs are. So we also look into several governmental related websites, such as the United States Department of Housing and Urban Development, better known as the HUD, as well as the United States Department of Agriculture, better known as the USDA. Last but not least, we also dive right into the National Agriculture Imagery Program, or better known as the NAIP, for satellite data. And right here on the screen, I have the overall project overview. So when we first started the project, we have this idea in mind of building an AI chat box that is able to address different housing issues targeted for different personas. So as you can see on the screen, we have 5 personas in mind, mainly the resident, the researcher, the community planner, housing agencies, as well as policymakers. At the same time, we were sourcing for different types of data. So the 4 main data types that we have are the structured data, which is the data for decision makers. We have the unstructured data, which is the RHRA documents, several housing policy documents, as well as a few satellite data. And the AI chatbot has the ability to look out for internet resources, for example, Wikipedia, for any housing related questions that it does not have the data for. Last but not least, we also look through several governmental websites, as mentioned at the beginning, such as HUD and USDA. So after passing the data sets to the model, it is able to train and understand all the data that was provided. So the AI chatbox is made up of mainly 2 components, which is the large language model, or better known as the LLM, as well as computer vision. So if you follow along on the slide, once the user produces a query to the AI chatbox, it is able to take in and interpret and understand the user's question before sourcing through the data sets to look for the right answers. So the outputs from the AI chatbox is mainly in 3 different types. It can be in the form of a map generation, in the form of a conversation-like response, or it is able to produce advanced analytics and visualization. So now the moment everyone has been waiting for, some of the use cases for our AI chatbox. So I'm going to take an example of how we can apply our AI chatbox on a particular document, mainly the USDA document. So let me give you a scenario. Let's say a newly elected city council members are unfamiliar with the past efforts to understand the local housing problems. But because we can all agree on there's so many housing data out there, it is hard to keep track of. So what the city council members can do is utilize our AI chat box. So right here, I have a video which I'm gonna play. So the person using this app could type in a question along the line of what are some housing issues mentioned in a USDA Rural Development Summary or Program. So after typing in a question, the model will take in the question, understand it before producing the output. As you can see on the output, I summarize the output as some of the housing issues mentioned in that particular document are mainly the single family housing, multi-family housing, and rural housing site loans. As you can see right on where my cursor is, it also produces a site where it retrieves the document from. And if you click on the link, it will lead you right to the document. So here we have the USDA Rural Development document that it gets its answer from. So here's the response that we get from the chat box. Okay. You guys must be wondering what exactly is happening behind the scene of the model. So as you can see we'll start from the very beginning. We gather all these unstructured data and we pass them and store them in a library. So the model, which is the large language model, is able to look and retrieve the data sets similar to the user's query. So after taking the user query, basically the model is able to understand and look for specific documents that best fits the user's question. After that, it is able to source for the specific documents and before releasing an output. So for example, let's say the user is asking some question related to housing policy. The model is able to look for documents specifically on housing policy and then find the most suitable answers before really producing an output for the user. Okay, so some of the, for the model performance, some of the strengths of our chat box is it is able to provide a very detailed explanation and elaboration of the answers. And the chatbot has the ability to look through several different types of unstructured documents. For example, the Word document or PDF. And as you can see from the previous response, it is able to cite the data source where the data is coming from. And it is definitely an improvement in the model's ability to interpret human language. Just by typing a simple English word, it is able to pick it up and produce a response. However, there are some of the weakness. Unfortunately, I don't know why this is cut off, but so some of the weakness that we have with this program, model is it has a relatively slow response time, which we have to optimize eventually. And sometimes you have to be pretty accurate and pretty precise in the way you word the sentence so that the model is able to understand. So some of the improvements that we can take in the future would definitely be optimizing the model to identify and verify data sources, making sure that the data that is given out is true and accurate. And last but not least, it's definitely important for us to expand the searches on academic research literature so that we can cover a wider range of topics. So why are we doing this? Why are we having the chat box to look through all the unstructured data? It is because it is, as I mentioned at the very beginning, it's very hard to keep track of all the housing data information. So by having these chatbots, it helps us improve the efficiency of accessing them and retrieving the right documents, because we don't want to spend tons of time looking through so many data, housing related documents where we could just, with a single click, we can get the right response. So right now, I'll pass the time to Neha, where she'll talk more about the structured data.
So thank you, Alistair, for talking about unstructured data. So we all know that unstructured data is where it generates and responds in the form of a textual and long paragraphs with the detailed information. Whereas when coming to unstructured data, it is very different. It's going to generate you interactive maps, tables for the user to make better visualizations. So let's start by going with local housing statistics and see how it works. So I'm looking at the problem statement and taking a scenario where a local official wants to apply for a federal housing grant, but he can't find the data that he needs. And he feels overwhelmed by the Census Bureau data. We all know that Census Bureau has so much vast data that anyone can be lost. And to get an accurate information that person is looking for in the information, it's hard for the Census Bureau data to look through. So let's see how our model will make that easy and be able to respond to this user's prompt. So as a user, I'm trying to ask a question to our model saying that as per ACA data, show the top 10 counties with median gross rent. And let's see how our model is able to respond to this prompt. So I have posted the question, it's trying to go through all the data, and it's coming up with a word accurate data that is relevant to the prompt asked. So as I have asked for top 10 counties, it has given the top 10 counties in Iowa. Because we have the Iowa data stored in our SQL, so it's given the top 10 counties in Iowa with median gross rent. And now I want to visualize it in the form of an interactive map. So I'm asking it a question to generate a map. So it's trying to refine the question and see the data. And it's trying to give the same data set which it gave in the first conversation. That means it's trying to follow up the questions. So based on the data sets, it's now trying to plot a map. So to see an enlarged version of the map, because users can't be able to see the small one. So we have an expand button where the user can click and see an enlarged version of the map for better understanding of the data. And whenever they click on the tooltip, they could see the detailed information in that county, what the user is looking for. And after you're done, you could just close the map. It also generated a source link, which directs you to the ACS Census Bureau website from where the data has been retrieved from. We have also implemented some of the UI features. For example, we have an sidebar where if there are so many chats and user is being confused where I have done a specific conversation and he want to go to that back to the conversation, he could just take the keyword that he's looking for, and we have a search feature where he could just enter that keyword and it'll shorten you the list of text information, and he could easily direct into the chat. As you can see, from 5 chat list, it just brought it to 2, which has that. And we also have a theme toggle where they could just go to the bright theme and light theme based on their user's requirement. If he feels that light theme is more better for him, he could just choose the light theme. We also have a small icon to clear the chat and start a new conversation. And I also forgot to mention about one of the feature that a user's question will be summarized and will be displayed in the sidebar. So the user can easily relocate his conversation. And also the response which has been generated will be at the bottom next to the user response. So these are some of the UI features that we have implemented for the user to easily access and interact with our language model. So what are the model performance? What are some of the strength of a model? The model can accurately identify and rank the counties with medium cross-rent. As we can see that it gave an accurate information and it was able to plot a map. That means our model can accurately and give clear responses. Of course, it could provide clear and relevant data that is easy to understand. It also integrated interactive maps to visualize data and to help and to explore the data more effectively. So based on the interactive maps, the user can more detailedly see the visualization of the data. So this is one of the scenario, but our model can also handle complex analysis and joins. So it could give you with 2 tables if you want to ask for 2 tables and more complex also, given comprehensive insights. So I don't know what is the reason the weakness has cut off, but I also want to point out the weaknesses. So as Alistair said, our model is in a starting stage. So you need to be more specific while. Oh, okay.
Can you switch this one? Technical issues. AI is not helping at the moment.
So the weakness is that you need to be more specific while asking the prompt to get in more precise results. Because at this point, as it is in a starting stage, you need to be more precise and accurate while asking the prompt to our model. So as you all know that, okay, I'm able to see the maps, I'm able to see the tables, everything is happening. But what is actually happening behind the hood? We don't know what is happening behind the scene. So that's what here is this. So whenever a user's query has been sent, it tries to rewrite and refine the query based on the chat history the LLM has. And based on it, it tries to search and retrieve the data set related to the user query. And then it builds a table related to the data sets, and then it's converted into table name, summary, and column name for better understanding. After that, it constructs an SQL query and retrieve the tabular data from a database for the decision makers. And this data has been retrieved from ACS data sets. And based on all the process, if the response should be in text format, it will show you in a text format. If it is in a table format, it will show you in tabular response. And if it is in a map format, it will generate your map. And the map is getting generated based on HTML using a mapping tool called Folium. So what are some of the improvements? So in future, we could try to improve the model ability to handle more complex queries. Instead of the simple queries and being more specific, it could be able to handle more complex ones. And also, we can refine the model to handle broader range of queries and integrate with our metadata to improve the accuracy. Also, we could add some UI features to make it easier for the user to interact with our language model more easily and conveniently. Apart from it, we could also integrate some more interactive tools. So right now we are able to show the interactive map, but in the future you could also show some graphs, charts, and other stuff for the user to better understand and visualize the data. So why is it important? Going back to our scenario, being a person who feels overwhelmed by the ACS Census Bureau data, and I have a problem that I want to know the median gross rent. I can't look through all the data in the ACS because it's too big and vast. So our AI model can make it easily accessible, providing a data and visualization for the data. Of course, it gives you an accurate responses and relevant, helping the user to make a better housing decisions. And also it's easy to, of course, because of the interactive maps and tables, it will be easy for the user to make exploration of the data. And of course, the information is more precise based on a specific question and a query you asked. So these enhancements make the housing information more accessible and actionable, aiding the community to build a better housing community. So I will pass the mic to Kale, who will be talking about segmentation.
Thank you, Neha. So yeah, I will be talking about our aerial imagery segmentation model that is implemented inside our AI chat box. So the scenario for this situation is if you're from Iowa, you know, especially this time of year, we get varying amounts of rainfall every year. Sometimes it's peak drought, sometimes it's very wet. And in this scenario, let's say that after consecutive days of flooding, the Mississippi River is rising and is now on the verge of flooding. And if you know, Guttenberg, Iowa is a small rural community in Clayton County, Iowa, out on the East Coast that borders right along the Mississippi. In this scenario, the Mississippi flooded, it's going into Guttenberg, and it's unfortunately caused a lot of damage to many homes and businesses within the community due to the rushing water. Where this segmentation model is helpful, in my opinion, is it can help with damage assessment as it's able to outline where the buildings were located based on the location within the image. And in doing so, it's able to locate, okay, there's supposed to be a building here, now nothing's here, or it's been damaged severely. So now we know how to assess what kind of damage has been caused. It is also can be helpful with navigation planning and rescue planning, as it can allow teams to have an idea of the area within, plan out where these buildings are located, and gives them an idea, okay, where do we need to target for any potential stranded residents. So here's kind of a demonstration within the model. So how you will prompt this is you can prompt the model to give you an image of a given census block or within a county. So in this area, we did Clayton County and we did block 3068, which is just within downtown Guttenberg, Iowa. After some time, so it's checking to make sure that this given input actually does exist. In this case, it does exist. And you can kind of see here is it will output what block you gave it, the county you gave it, and then it outputs the number of buildings that the model thinks it's located in the given area. So in this case, it's identified 9. And the 2 images below on the left side is the true image given from the NEIP data set that we use. And on the right side is the segmented image that the model is predicted. And it's giving the outlines of what it's thinking is a building. So anything that you see in the right image is red. That is what it's identifying as a building. Anything in white is what it's just considering as an environment. And there's a reason why there's only 2 in this case that I'll talk about here next. So behind the scenes, if we start up in the orange arrow up in the top right corner, the 3 main areas or 3 main data sets that was used for this was the NEIP, or the National Agriculture Imagery Program images. We used the Des Moines data portal as a way to be able to give the location of the specific buildings and be able to know their outlines, as well as the U.S. decennial data of 2020 to help us with cutting out the specific locations within the NEIP image for a given area. From there, what happens is the images are collected, so it takes each areas of each of the buildings and of each block, it cuts it out of the NEIP images, and it stores them later to be used for image preprocessing. The reason for image preprocessing is that it takes each of those images and each of those building locations, and it color converts them, and it resizes the image to be able to fit to the specific needs of our pre-trained model. Pre-trained model just means that it was a model that was formally pre-trained, but now we're going to perform fine-tuning on. After pre-processing, those images then get split into 2 separate groups. One group is set to design for the fine tuning and training, and the other is set for testing and validation. The reason we do this is that it allows the model a way to be able to give out some sort of accuracy measurement so we understand how well the model is performing while it is fine tuning. So for fine tuning, the pre-trained model that we use is called segformer, which is a form of segmentation model. And the reason why we need to do fine tuning is like I said, we only had 2 image classes used for our specific model. We had environment, which was set to 0, and image was set to 1. The pre-trained model had 35. So it ranged from various different objects, but we only wanted to focus on 2. So where fine tuning comes in is that we give these 2 classifications that we want, we apply that to the model, we give it our resized and recolored images from our training set, and we then retrain it onto our specific needs. Then from there, once the model completes training and it gets saved, and this is where it gets applied to our user interface chat box. From there, and that's where you can use the user's given query for a specific county in Iowa, as well as the desired block number, and then it takes it and it will go through to make sure that what you gave it actually exists. If it does exist, it will output the image and the number of buildings that you want. And if it doesn't exist, it will go through, tell you that this combination doesn't exist, and re-prompt you to enter again. And through that inference, those images, while it's searching for those, if it finds it, it goes through that image pre-processing again, just so when the model gets applied for giving the outlines, it's in the same format that the model is requesting. So the biggest strengths that this model has is homes and businesses and other large buildings. It does very well at outlining those very easily. In any given area, because we really wanted to focus this on trying to use for rural locations, so it does really well there. Sometimes it has instances where it actually is able to identify a building that previous data has not seen. So one instance I saw is when I was going through, I had a block given in Cerro Gordo County. There was a new house built within a rural farming location that the true image and the true outline didn't recognize that it was there, but the predictive model recognized that it was there. And you could very clearly see that there was a new house that had just been built within the last few years. And then the last thing, one of the biggest strengths is that it can go statewide. It's able to range all across Iowa, all across the blocks, and give you a very high quality, high resolution image for you to see. Unfortunately, there are some weaknesses to this. One of the biggest ones is trees are our biggest nightmare in this scenario. The reason I say that is that because of the images, trees cause some covering of a building's location. So the model will be able to see maybe a specific corner and outline that, but the tree sometimes will cause it to not recognize what's underneath. Some scenarios it still will, some scenarios it doesn't. So that's where the trees are a really big issue. The second one is also shadows within an image. Where the shadows really hurt it is for very small buildings, such as maybe you just have a shed in your backyard, you have a small doghouse. Those aren't able to be identified because they're in such dark locations. The model isn't able to recognize it with the classifications that we gave it. So this goes into our improvements that can be made. One is expanding it beyond the census blocks. Right now the model is restricted to very small areas, and this is because of where the data is coming from. It has some size restrictions from what you can request from where it's gathering. Another improvement would be distinguishing between different types of buildings. So between one is a house, one is a shed, maybe one's a silo or a bin. Being able to help distinguish between that will help better with, going back to our scenario, maybe the damage assessment. And also expanding to more classifications. For example, going back to that scenario, expanding it to flooded areas. So being able to give the flooded area outline along with the building outline to help with navigation and to be able to get a better idea of the overall image and what's going on in the real world. So why is this important? The reason why this is important to our overall project is it allows a way to give a real life visualization to the users, because as we all know, everybody has a different style of learning how they intake information. Some people are more textual and more informational, some are more visual. So this provides a way that the user is able to get a visual representation of what's going on in a specific area. Say you asked it for a specific data related to a certain block. This provides a way to how you can see what's in that area and why there may be a correlation between what's going on in the data and what's actually going on in the real world. And it also gains a better understanding of the overall region, as it allows you to kind of visualize, okay, this is a very densely populated, densely built area. Maybe it's within a city, or it's maybe within a suburb, or it's just a very widespread rural farming area. Yeah. So to kind of start concluding all this, so the 4 main areas of our project goals that we really hit on was, one, in our large language model, which is the model that's able to intake a user's query to then be able to expand it and output any sort of data, the data that you requested within our targeted areas. We've also helped develop a large knowledge base of many different documents, many of the ACS data, as well as the aerial images, to help with be able to recognize to help be able to correlate what the user is requesting. We also have the satellite imagery and the aerial imagery model that is able to give the outputs of specific buildings in a given image for the user to help better visualize everything, as well as a nice user interface as a more friendly way to help connect between a user and the AI model in a more friendly and more friendly manner to give more clear and concise results to them. Yeah. So to kind of wrap up, the overall goal going forward is we wanted to make sure housing data is more easily available, because like we said, kind of throughout the project, is rural community data especially is very hard to come by if you ever try to look for it. So this is kind of a way to give it out to more of those rural communities, or even anybody in the community, more easily and more quickly accurate information. We also want to make sure that the user is getting more constant and up-to-date data as well, because going back to the satellite imagery, those images get updated every year, as well as the ACS and decennial data updates every year as well. So being able to make sure that they're getting more up-to-date and more accurate data is very important. We also want to make sure that it is more time efficient as a way to, or more time efficient so it's not tedious to the user to have to use it rather than an alternate source. And then also kind of use it as an AI being the better solution to providing data rather than just going through Google and potentially just getting lost in every Google search that you make. Because sometimes that you can just get caught in a constant loop within your Google search. So for future work and challenges going forward, one of the big things is expanding our data sets. We kind of really focused on 4 specific areas that with the limited time that we had. So expanding it to many different data sources, many different documents to be able to gather more information to spread across more areas within the housing industry would be very important. Expanding the fine tuning is expanding our segmentation model to be able to locate and be able to outline many different classifications. So just going beyond just building an environment that we have right now. Evaluation is a way to expand some sort of a feedback system. If you know with ChatGPT, they have sort of a feedback system that gives you a way of saying if the information maybe you're getting isn't helpful or isn't accurate. It allows it a way to give it back, and it allows us a way to evaluate if the model is doing what it needs to and what areas do we need to do to help improve it overall. And finally is performance. Although large language models have a very long processing time, even with higher speed computers that we have, it still takes a bit of time to load a user's query. So being able to help speed that up to be able to be a bit more time efficient is definitely one of the challenges we face and one of the things we would want to improve upon.
So going with what we learned. So we learned the ability to modify the classification of the image, such as color, size, and to use that image information for our future techniques. And also, we have used the data sets. We have used the different types of data sets to integrate with a large language model, and we have trained the desired data sets to give and specific to answer the user's query. Also, additionally, we have also have the source data, which is based on the housing policy so that it could answer more accurately the housing questions. Furthermore, we have also integrated some of the interactive map using the mapping functions, and we have added some UI features for the user to access and facilitate interact with a large language model. So overall, we all together work together and try to answer the housing policies and needs.
It wouldn't be a fitting end to end us off by giving a huge shout out to the people that have been with us throughout this whole 10 weeks, through the highs and lows. We as a team are actually grateful to our sponsor, our clients, our project lead, who unfortunately is not here, he's online, and Lisa over right there. And last but not least, huge shout out to our best event coordinator, Harun. Yeah, and yeah, we wouldn't be here. We wouldn't have that much, have a functioning AI chatbots without you guys. And before I forget, I want to thank you guys for those that are present physically and for those online. And yeah, we look forward to see how these AI chatbots can benefit the users from all walks of life. We're excited about it. And before I forget, we do have resources that we will look through in completing the project for a future reference. That's all from us. Thank you.